This is question 17 from the first CSAT sample paper. So we're told that ln is the number of sequences of zeros and ones of length n without adjacent zeros. It can have 2 or 3 or 4 or however many ones next to each other, but it can't have any number of zeros next to each other. And we're asked to give a recursive formula for it. So that means we're asked to define ln in terms of, say, ln minus 1, maybe ln minus 2, ln minus 3, however many of those we need. So if you want to have a go at this question yourself, pause the video now. Okay, so first of all, let's think about what's happening with these sequences. We're looking for a recursive formula, so that makes me think, I've got to think about what happens at n in terms of n minus 1 and maybe smaller lengths. So it makes sense to think about, let's say we've got a short sequence of zeros and ones without adjacent zeros. How can I build another one from it? And there's a couple of ways you can go. You could say add ones and zeros at the front or at the end. Let's just think about adding them at the front. So you could do this either way, but we'll think about adding them at the front. So let's start with just a sequence 1, 0, 1, so this doesn't have any adjacent zeros. And now we want to think about what we can add at the front. Well, if we add either a 0 or 1 at the front, it will give us another sequence which doesn't have adjacent zeros. So now we might try and do the same thing to these, but what happens is we can add 0 or 1 in front of this, that's fine, but we can't add 0 or 1 in front of this, we can only add 1, because otherwise we'll have 2 zeros in a row. So we can get 2 more from here, but only 1 more from here. So the thing to see is, if we imagine getting a new sequence by adding 1 or 0 in front of the old one, we have to worry about whether the old sequence started with 1 or 0. If it starts with 1, we can add 2 more. If it starts with 0, we can only add 1 more. So how are we going to deal with this? I think the easiest way is, instead of going for this directly, invent 2 new numbers, one of which counts the number of sequences of zeros and ones of length n without adjacent zeros that start with 1, so this case, and another one that counts the same thing but starting with 0, because then ln will just be the sum of those 2. Okay, so I've defined these as functions f and g. Fn is the number started with 0, so the number of sequences of zeros and ones of length n without adjacent zeros, starting with 0, and gn is the same but for those starting with 1. So now let's think about the recursive part. So we want to think about f of n plus 1 and g of n plus 1. So how can I make a new, suppose I have a bunch of sequences, how can I make a new one that starts with 0 and doesn't have adjacent zeros? Well, that means I can take one that starts with 1 and add a 0 in front, and that will be fine, but I can't take one that starts with 0 and add a 0 in front. So that means that if I'm looking for f of n plus 1, so the ones of length n plus 1 starting with 0, all I can do is take all of the ones that started with 1 before and add a 0 in front, so I get a new one for every one of these that now starts with 0. So that means f of n plus 1 is equal to g of n. If we think about g of n plus 1, well, I can either take a sequence that started with 0, or I can take a sequence that started with 1 and then add a 1 in front. So that means I get g of n plus 1 is all the things that started with 0 before, plus all the things that started with 1, and I'm just taking all of these and putting a 1 in front. So I get these 2 recursive formulae involving f and g. So now let's use these to try and get a recursive formula for ln, or ln plus 1. So ln plus 1 is just the sum of these. Either a sequence starts with 0 or 1, so if I add together these 2, I get all the sequences. So ln plus 1 is f of n plus 1 plus g of n plus 1. And what I want to do is to start rearranging this so it's in terms of ln and maybe ln minus 1, ln minus 2, etc. So first I'll just use these formulae. So f of n plus 1 is gn, and g of n plus 1 is fn plus gn. So this bit's fine because this is going to be ln, but then I've got this extra gn at the front that I don't want. And the trick here is to see that I can get rid of this using this again, and it gives me an f plus g. So I can make this fn minus 1 plus gn minus 1 using this line again. And then I'm keeping this bit the same because this is just going to become ln, and now this is going to become ln minus 1. So we get ln plus 1 equals ln minus 1 plus ln, and this is a recursive formula. But we're not quite done yet because we also need to give the first couple of terms to complete our formula. So I've written L1 is 2. Why is that true? L1 is just the sequences of length 1, so it can either be a 1 or a 0, so there's two possibilities. And then L2, what can that be? It could be 1, 1, 1, 0, 0, 1, but not 0, 0, because that would have two adjacent zeros. So L2 is 3, so these can be our first two terms. I'll just add, we could have started with sequences of length 0, so we imagine there's one of those, which is like the empty sequence. But you might not want to do this in case you think the empty sequence doesn't make sense. So you could start with L0 is 1 and L1 is 2, or you could start with these two. You could do it either way and you get the same answer. So this is our finished recursive definition. Ln plus 1 is ln minus 1 plus ln. That should look familiar, by the way. And we'll take these two to be our first two terms.